So to start this off, who am I? As I said, Peter Souter. I'm a professional service engineer at Puppet Labs. My career path has been kind of strange. I started off doing support, then kind of moved into development, starting off with Java and then into Ruby. Then after that, moved into operations, and now I'm working professional services at Puppet Labs. And professional services is kind of funny because it's a mixture of all those put together. We're supporting customers, we're helping develop modules for them, and we're also working on site as operations. So what's this all about? I've been wanting to give a talk about something for a while, and I sort of thought about what do I actually know about. I've done ops at a lot of different places now. I've worked at SMEs, government projects, banks, startups, and I've seen a lot of different ways of doing ops. I've heard a lot of opinions, and have some of my own of how they should be done. So that's when I thought, let's do a talk on a basic summary of Agile ideas and how they work for operations. So I'll start off with some caveats. None of what I'm going to be saying in the next 20 minutes or so is going to be anything new. It's basically a summary of existing ideas already out there, plus some of my personal experiences. And even though I'm from Puppet Labs, and obviously have a vested interest in one of the tools in particular, I'll try not to talk about tools specifically, because it's all about Agile, people over processes over tools. And the last caveat is this is my first ever talk at a conference, and it's taking all my willpower not to run off screen right now. So I'm trying to keep it slow and keep it cool. So let's start off with why do I care? So as I said, when I sort of learned most of my craft when I was doing development. When I was doing support, it was just sort of standard support. When I started doing operations after I was doing development, I wanted to use all the cool Agile stuff that I'd learned in operations there. And when people engage with pro services from Puppet Labs, sometimes they're on the ground floor of Agile processes, especially when it comes to agility within operations itself. So making things Agile increases the customer's chance of success, makes them happy, which increases our chance of success with the engagement overall, which makes us happy. So why should you care? I mean, hopefully if you're here, you're pro-Agile anyway, but if you're not, you should be. It's a nice little graph, I'm not sure if you can see at the back, from the 9th Annual State of Agile Survey. For the last 4 years running, the ability to deal with changing demands has always been the number one, but as you can see, things are generally better with Agile. So to start off with, let's talk about the Agile Principles and how they apply to operations. So what are the Agile Principles? I'm going to read them out really slowly here. No, I'm not really. There's a lot of principles there. It's a pretty long list. So let's make that into a nice summary. It's a pretty good summary by Boham and Turner. And they sort of break it down into 4 main attributes: iterative, incremental, self-organizing, and emergence. Those are the 4 Agile attributes that they see. So how do each one of these processes or attributes apply to operations? So to start off with iteration, there's a definition of iteration there. Basically the idea of making progress through successive and continuous refinement. So there's a Roman proverb which is a man who chases 2 rabbits catches none. And a lot of the ideas that come from development iteration are the same for operations too. There's always lots to do. You've always got the problems with how long it takes to create new servers, you've got things that are out of date, you've got new load balancers, there's new toys to play with, there's always something to do in operations. So iteration is mainly about limiting that work in progress. So the easiest iteration is deploying often, because the deployment is really the main iteration you're going to be doing. It's when customers see your product or service and be able to interact with it. And if you haven't, you should be automating that process to make it easier and make it repeatable. And if it's a painful process, you'd be finding out why and you should be fixing that problem. And the biggest example of iterate operations is continuous delivery, but I'll come back to it a bit later. So the second attribute is being incremental. So the idea of building software in pieces, and each little piece is a little subset of the whole thing. So a little quote there from Henry Ford, sort of the main person behind the idea of assembly line production. Nothing is particularly hard if you break it down into small jobs. So this is going to be an extremely overused image, and if you've talked about lean or researched or even know what MVP stands for, then you've probably seen this image a lot. But it's the idea that instead of having a customer who's not happy until you deliver the whole thing, You deliver something that might be slightly like the thing and keep developing on it and keep iterating and incrementally increasing that thing. So this works for systems as well and operations. So the days of gold disk servers should be over. And the big bang delivery of a system or server smells of waterfall. You should be delivering incremental parts of a system. And there's already some tools that you can use to help out with this. Obviously, there's a Puppet, Chef, Ansible, Salt. And together they're known as infrastructure as code. And this really helps with incremental changes because you can treat it like you would treat any other code. You can do small features, you can do little iterations on it. And with most of these tools, there's lots of pre-existing knowledge out there. For example, with Puppet, there's the Forge, and then it'll be hundreds of modules for most of the common things you can think of deploying, Apache, Nginx, and that kind of thing. So there's a lot of pre-existing knowledge out there for that. And the cool thing about infrastructure as code is that you can treat the development just like you treat agile development of just regular code. You can do unit testing, you can do BDD, and you can do pair programming. And I actually do BDD when I write Puppet code. So this is an example of, if you're familiar with Ruby, you can see this is some RSpec code. This is an example of, I was at a customer site recently, and they had some Apache work that they needed automating. So they already had an idea of what it should look like, and they didn't care about a lot of the Apache config because most of it, they weren't sure about every little bit of it. There are some things they really cared about, and those are the bits that I turned into the test. So you've got the config there, and it's saying the content should have the proxy path and has custom logging to a certain place. It's saying that Apache should be running, it should be listening. And you can even do little complex things like this, where you can actually curl, or you can actually run a command, and then the standard output from that command should do something. And on a personal note, I probably learned the most ops from pairing on infrastructure as code, because it gives you sort of a nice overarching look on how things are done. Because you get to look at, when I paired with someone, we have a problem. You get to look at how they investigate the problem on the actual system itself, and then how they fix the problem in the infrastructure as code. In my case, that would be Puppet. And the little you learn little tricks and things on how to do things, little Linux commands and that kind of thing. They're really useful. And another thing that can help with incrementalness is platform as a service or infrastructure as a service. You've got the sort of Blue Peter effect of here's one I prepared earlier. There's a pretty good blog post on the GDS blog about this and talk about why they use infrastructure as a service. And the idea is that instead of having to get all these specialist skills in-house, sometimes if there's already existing knowledge out there and already a private company that can do these things, it can save you a lot of time to get things out there. I'm not saying you should use infrastructure as a service or platform as a service for everything, but you can break tasks down into small, more incremental chunks. So the third attribute is self-organizing. And the idea is that the people within a team should have the ability and authority to take decisions and readily adapt to changing demands. That's the core concept of Agile and its main benefit according to the Agile survey. So there's multiple models of how they've seen this work with ops as a team. Little audience interaction here. I want to see which one you use. So put your hands up if you're a big siloed ops team. Well, that's good, because that's a bad thing most of the time. Put your hand up if you've got embedded ops people on each team. 2 or 3 people there. And the last one is the hybrid of the 2 previous approaches, mixture of an embedded ops team, but you also have a specialist ops team. Okay, that's pretty much everyone else. That's the most common I've seen. It's the one that I've encountered most of the times on site. So when you're self-organizing, size obviously matters. When you're an 8-person team with 1 ops person, things are pretty easy because you can probably fit most people in 1 room. You don't really have to worry about organizing too much because everyone's in one place. You can talk to each other face to face. It's quite easy to do that kind of thing. And things really start to get interesting when you've got enough ops people to form their own ops team. And when you've got 100 people self-organizing, especially with operations, you can start to have problems. And you definitely can't do it all. There has to be some level of direction. Remember the quote from earlier on the Roman proverb, you can't catch 2 rabbits at the same time. So there's a pretty good blog post about choosing boring technology when you're self-organizing. There's like the main quote from the blog post. But the particular summary, the little highlighted bit I want to talk about is the weight of the day-to-day operational toll that choosing these non-boring technologies crushes you to death. And the idea of picking boring technology when you're self-organizing is super important right now. Because things like Docker and microservices, whilst really cool, they're definitely not a free lunch. In fact, speaking as an ops person, a lot of these times, these actually put a lot more strain on operations themselves. Because, for example, with microservices, you go from having to maintain, deploy, and package one big monolith into having to maintain, deploy sometimes hundreds, sometimes even thousands of microservices, which is definitely a big thing that operations teams are going to have to deal with. And using a hybrid approach has its problems too when you're talking about an operations team. You definitely can have mixed priorities. Sometimes you have a dev team with an ops person on it with no ops stories. Or sometimes you can have the opposite problem where you have two conflicting, you have an ops-related story that's really specific for a feature that a developer wants. We also have a really important operations story that needs to be done right now. So it's hard to balance between the two. And there's also the problem of the tension between skills as teams or spreading skills out. This is nothing new. This is not just an operations problem. You also have this with design, with UX, security, performance, anything that's not seen as core dev. So what's the main solution to this? Obviously, it sounds way easier to say than do. But the idea is to push the problems down to the point where people can get it done. So this is obviously a massive culture shift. You have to start bearing the cost of decisions and let people optimize for themselves, and let them get the thing delivered. I mean, that's the core principle of self-organizing. So the last one is emergence. And the idea is that you deliver functionality and let the design emerge. And overly prescriptive design and frameworks often cause a bottleneck, and this especially applies to operations. There's a nice quote from the DevOps report, the latest one. Adopting a framework wholesale without reference to particular issues of the workplace often makes life more difficult for everyone. And it specifically mentions ITIL and COVID there. And it's not, it's not just dissing on ITIL and COVID, it's just saying, don't just pick a framework just because you think it might fix things, especially when you haven't really talked about it. And the idea of just picking a framework, it might sound familiar to you. So most of these have just been core Agile ideas and haven't really specifically applied to operations with a few exceptions. So you're probably thinking, if only there was some new approach for agility within operations. So that's when I start using the D word. So we're going to talk about DevOps. So where does DevOps fit into all of this that I've been talking about? So DevOps itself was actually a basic response to the lack of agility within operations teams. So Patrick Dubois, who's the sort of godfather of DevOps, he was the first person to start talking about it. I think it was an Agile conference in 2008 was when he first started using the term. And he specifically talked about how when you first organized the first DevOps days, the gap he wanted to close was to integrate operations and system administrators into Agile methodologies, which is exactly what I'm talking about right now. So a common misconception, and it doesn't really help that the name itself is a little bit of a misnomer. DevOps is not just ops people doing dev and dev people opsing. It's mainly the next step of Agile methodologies. There's a nice little diagram here from Matthias Marshall, who works for Chef right now. The idea is that DevOps is this last container here. Within that, you've got lean product development here, you've got operations itself, and you've got Agile development, Scrum, Kanban right here. I think this is actually a slightly, this should be edited a bit, because this operations bit should be part of the Agile process, but it's a general idea. And you've got the principles itself, like this is what lean is, and this is how this fits into lean. And you've got the idea here, and the actual execution. So the DevOps core values line up and extend the Agile attributes that I was talking about before. And then DevOps core values are often called CAMs, which stands for culture, automation, measurement, and sharing. So as we talked about before, this is a culture shift. And a drinking game for talking about Conways Law. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And this especially is what DevOps is mainly all about. If you have some super cool, lean, agile team, agile dev team doing all this cool stuff, but then they just throw it over all to operations, then that's going to be reflected in the product itself. It's not going to be deployed right. It's not going to be in front of the customers as soon as possible. You need to have this. You need to have a shared responsibility for all this, just like in this image. So DevOps itself shouldn't be a title, and it shouldn't be a team. You shouldn't have a DevOps team. Everyone should be DevOps. And you shouldn't have a DevOps engineer. Everybody should be doing DevOps. It should be a massive cultural shift. And there's a pretty good image from the Martin Fowler blog about what DevOps and what DevOps collaboration should be, and how this is pretty indicative of, it really lines up with the Agile principles we were talking about before. So you've got autonomous teams, that's obviously self-organizing, being able to do that kind of thing. You've got automation, which doesn't directly line up with any of the attributes, but when you automate things, it makes iteration and incremental development way easier. And you've got building quality in. You've got feedback, which obviously comes in part of the incremental and iterative designs. And you've got the idea of no silos, and that's the idea that people should be organizing, they shouldn't have to worry about communication within the team. And this is another image, this is by Gene Kim, and basically it's, what is the DevOps vision? And the idea is that you see the system, you focus on the flow within that system, you recognize those feedback loops, and you look for continuous improvement opportunities. And obviously this is the core idea of incremental and iterative design. So then a question I get a lot is, where does some other specialization fit into all this? And there's a pretty good tweet by Pete Cheslock when he's talking about where does security fit with the DevOps plan. So as I said before, the DevOps is actually a misnomer. It should be called something like DevSec UX Perf Ops or some other term. I don't know what the term would be. But it's not just about Dev and Ops. It's about having one unified team with cultural, being able to share culture between the two and have sort of a unifying vision of getting everything done. So the A in CAMS is for automation. And automation makes all the other stuff easier. And the ideal sort of situation you can be in is that iteration and incremental development become trivial when automated. That isn't always how it ends up being, but that's the dream. So continuous delivery is the ultimate use of automation. And there's a bit of a misnomer when it comes to continuous delivery. People think that means that you have to deploy code that you've just made directly to production every single time. That's not actually what it's about. It should be in a deliverable state, but it doesn't have to be deployed immediately. That does help, but it's not really what it always has to be about. So the M in CAMS is for measurement. And you can't improve and iterate and incrementally develop if you don't know what you actually need to improve. And measurement isn't just pretty graphs on a big screen in the ops area. I mean, obviously that looks nice, and it means that you've got a lot more visibility for the ops people and what they're doing. But there's more to it than that. You've got anonymous surveys, you've got the Agile favorite retrospectives, you've got post-mortems on incidents. The Google operations blog has really good post-mortems when they talk about outages. They talk about what went wrong and who and why it went wrong and what steps they have in the future to go and fix those problems. Excuse me. And they're really good, especially for customers, with, no one ever looks good when there's an outage or anything like that. But a lot of times it can increase customer confidence if you read one of these blogs and find out why the problem happened and what steps that you have in the future to prevent it. And obviously you've got the last one, which is metrics. So Etsy are behind the tool called StatsD. It's basically the idea of a stats daemon that you can give all these cool metrics and get all these information out of. And Etsy even have the idea of you have metrics-driven engineering. And when you have these kind of metrics and the level of detail that they have, if you read one of their blog posts, you can just see it really drills down. Like you've got every single level, even for operations things, but also customer interaction. You can really start to increment and iterate on what you need to do because you can really see what the problems are. You actually have a data set to improve it. A lot of times you start talking about, we need to do X because Y, and someone says, do you actually have any proof of that? And a lot of the time you really don't. You just have a gut feeling or you have a sort of general idea. If you can get really good metrics, not just like data metrics, but information from the retrospectives and surveys, you can really start to get things out there and develop way better. And the S is for sharing. So speakers, internal or external, sessions, pairing on things. I really like the idea of pairing operations, not just for infrastructure as code, but for investigating things. When I started doing operations, because I came from a support background, I sort of only really knew sort of by the number support. So I didn't really know too much about the sort of deep networking problems that you can get and things like DNS. So the first thing that the the best way I learned those kind of things was that someone said, we had a problem with this DNS problem or this networking problem. And I said, can I just sit next to you and see how that goes and find out how you would investigate that in the first place and how you'd fix that. And then I started to learn all about the tools that you use to investigate those things, like Dig, and figure out how they fixed it and what websites and what applications they were using to fix these problems. That was really good. And blog posts, obviously. And speaking in general, like this for me is part of the S of CAMS, is sharing these ideas, even if these ideas might not be entirely new for some people. You definitely learn a lot when you're doing these things. So the general summary of that is that DevOps makes it better. So the DevOps report, the main summary of, they've got some pretty good hard data on this and talk about how DevOps organizations are normally more successful and from various metrics like being able to deliver faster and that kind of thing. But the sort of main summary is organizational investment in DevOps is predictive of organizational performance. So the more DevOps you are, generally, the better you will do. So where do you go after this? What do you do after you've got your cool DevOps things set up in place? So I'm not super sure. One of the ideas I've heard about is operations as a service team. There's a pretty good book called Designing Delivery, Rethinking IT in the Digital Service Economy. So when I wrote these slides, this book had literally just come out. My plan was to read up on it and throw some information in here about that. But I've been super busy, so I haven't had a chance. But if anyone wants to read that and tell me it was good or not, that'd be really good. So no endorsement there. I've just read that it's a very good book for this kind of thing. I mean, operations as a service team, it does not mean you're a ticketing system, because you should be breaking down these silos. You should be being able to self-organize and share. And having the system where developers are back to the old days of throwing things over the wall and then getting a wall of silence in response because they have to wait for a ticketing system, you're definitely going back from that. But a good example of how to do this without becoming a ticketing system is GDS. So there's already been some talks, and there's already been people who've worked within the GDS and the exemplars. And I've worked on some of the GDS examples and the exemplars, and the operations team there is just, they're really, really good at what they do. And it's really good for teams when they only have a few operations people who might not have some of these skills that are needed for these large government projects, to be able to consult with these operations service teams and figure out what previous experience there is and what other cool things you can do. So would you like to know more about this? I'd recommend reading The Phoenix Project by Gene Kim. It's a bit weird because it's a fiction book about a fictionalized company, about how they deal with the DevOps problem. But it's pretty interesting, especially it's really useful for managers if they're having trouble sort of understanding why DevOps is good. You've got the Jez Humble and David Farley Actual Continuous Delivery book. You've got the Visible Ops book by Kevin Baer. If you're into Twitter stuff and you want to follow people, it's a list of cool Twitter people to follow. There's Anna Shipman, Technical Architect at GDS, has some really good blog posts about how operations work at GDS. Got Chris Bryant, who's the organizer of Config Management Camp. Jez Humble, who's obviously the book author of Continuous Delivery. Got Gene Kim, who wrote the Phoenix Project. Patrick Dubois, who's often seen as the godfather of the term DevOps, if not just DevOps itself. And there's tons more to follow. If you're really into Twitter lists, there's a Puppet Labs list of DevOps accounts and people to follow there. Apart from that, you can also, there's DevOps Days. I couldn't find a DevOps Days in Wales, but there is a DevOps Cardiff meetup. Maybe someone who lives locally could do a DevOps Days in Wales. That'd be pretty cool. There's a DevOps Weekly newsletter run by Gareth Rushgrove, who was previously at GDS and now at Puppet Labs. It's a really cool summary of not just the tools, but also cool cultural and blog posts about cool DevOps topics. The DevOps newsletter, that's a bit more about tools by server entity, but it's still pretty good. And there's the GDS blog itself. And remember the S in CAMS is remember to share these things and learn these kind of things. So as I said, this is my first ever conference talk, so I want to get feedback and questions and comments. And in the spirit of Agile, I want to iterate and incrementally improve this presentation. So yeah, that's it. Any questions or comments or anything like that? Okay. Thank you very much for listening.